Okay, we're going to do practice C, practice 2C, 1 through 3, and 2D, also 1 through 3. So practice 2C has to do with displacement with constant acceleration, and D has to do with velocity and displacement with constant acceleration. So let's look at number 3. So I'm doing 2C first. So I'm going to write my given, and I'm going to write my find. Okay. So it says a rocket traveling at 88 meters per second is accelerated uniformly to. So if it's at 88, that's its initial velocity. And then it goes to 132. So that's my final velocity. So again, the key word here is to. Over a 15-second interval. What is the distance in meters does the rocket travel during this time? So I want to find x. So what are my variables? So I have the I have the f, I have t, and I want to find x. So if you notice, there's no acceleration here. So the equation here for these 4 variables is x is equal to vi plus vf over 2 times t. So I want to solve for x. I'm just going to substitute in my values. So x is equal to 88 meters per second plus 132 meters per second divided by 2 times 15 seconds. So let's put that on our calculator. 88 plus 132 equals divided by 2 equals times 15 equals, and it comes out to be 1,650 meters. Now, if you look at the answer on the sheet in parentheses, it's in correct significant figures. So it has to be 3 significant figures. So this is going to round to, 2 significant figures, because this is 2, 3, 2. So to get this to be 2 significant figures, we'll make it 1,700. So this is the answer you're going to get on your calculator. But if you're taking a multiple choice test, that's going to be the answer that you're going to see on your multiple choice test. Okay. So remember that all standardized tests use significant figures in high school and college. And it doesn't matter what class you're taking, biology, chemistry, physics, geology, astronomy, all the answers are going to be in correct significant figures. All right, let's go on to practice D. So practice D is a different equation. So we're going to do D3. And that other one was C3, not C2. So this was C2, C3, and D3. All right, so again, we're always going to write our given and our find. All right, so it says the Tokyo Express is uniformly accelerated from rest. So remember, from rest, that means the initial velocity is 0. To 1 meter per second squared. So meters per second squared, is that velocity? No, that's acceleration. So you need to know that meters per second squared, that unit is acceleration. Okay. For 1 minute. So the time is equal to 1 minute. So now the question says, how far does it travel? So I want to find x. Well, first of all, I'm going to say to myself, this is seconds squared, and that's minutes. So those aren't going to cancel. So I'm going to go say 1 minute. Whoops, 1 minute. I'm going to put this over 1, and I'm going to convert that to seconds. So if minutes is in the numerator, I put in the denominator, and I want to go from minutes to seconds, and there's 60 seconds in 1 minute. So this would just be 60 seconds. So t is equal to 60 seconds, and that's the way I'm going to put it in my equations. All right, so now let's get back to the physics. I have VI, I have A, I have T, and I want to find X. So now I'm going to look at all my equations on my blue sheet, and I'm going to say which variable, which equation has those 4 variables. So it's X is equal to VIT plus 1/2 AT squared. Now, anything times 0 is 0. So this whole term goes to a 0. We do an upward arrow to the right, which means something goes to 0. So 0 plus 1/2, 1.0 meters per second squared times 60 seconds. So 60 times 1 is 60 divided by, oh, we have to square this. So 60 squared times 1 divided by 2 equals, so it comes out to be 1,800. So X is 1,800 meters. And I didn't do it on the last problem, but I'll do it on this one, and maybe I'll go back to the other one. Remember, if I carry my units through and cancel them, it's a foolproof way to check my work. So I have meters per second squared. When I square the 60, I square the second squared. And then you see these cancel, and I end up with the correct unit, which is meters for displacement. In the problem above, if we went back and checked our words, we would have a meter per second times a second, and these would cancel, and then I see I didn't make a mistake. So in physics, you always have a foolproof way to check your work to make sure that you didn't make an algebra mistake. You just have to carry your units through and cancel them. And if you do it step by step, you write your given, you write your find, you do a conversion if you need to. Here's my 3 that are given, the one I want to find, and then the problem solves itself.